Afternoon, everyone. You're very welcome to this ASHRAE Ireland technical webinar. My name is Daniel Coakley, and I'll be chairing today's session. So before we begin, here's the agenda for today. I'll give a short introduction and cover some housekeeping and general information before handing over to Dr. Clayton Miller for today's technical presentation. And after Clayton's presentation, we should have around 10 minutes for short Q&A. So just if this is the first time that you've attended one of these webinars, I just wanted to highlight a couple of points regarding your participation. So as you'll have noticed, everyone's muted by default, but if you want to ask a question, please use the questions tab or the chat function to submit your query, and we'll do our best to answer it during the webinar. You can also submit your questions at any time, so feel free to submit them as soon as you have them, and we'll do our best to get to them at the end. If you have any difficulties or you want to follow up afterwards, email contact details have been provided for myself, and I think Clayton is going to share his as well during his presentation. You can also access a PDF copy in the handout section of GoToWebinar, so there should be a PDF copy of my presentation and Clayton's presentation available there. And finally, when the webinar is finished, you'll receive a very short survey, just 3 questions. We'd really appreciate your response on to gather feedback about these presentations. So this is part of our 2021 technical webinar series. This is just a list of the presentations we've had over the last couple of months. You can access videos for all of these previous presentations on our YouTube channel, and you can access them directly using the links provided on this slide. I just wanted to highlight as well the training that's always available through the ASHRAE Learning Institute. They run a range of courses which are available on the ashrae.org website. So if you go to the link at the top of that slide, I've just summarized here the upcoming courses over the next 2 or 3 months. So just go to the ashrae.org website and you'll be able to register and attend those presentations. So without any further ado, I'm going to hand over to today's speaker, and I'm delighted to welcome Dr. Clayton Miller, Assistant Professor at the National University of Singapore, where he leads the Building and Urban Data Science Lab. Clayton's work focuses on leveraging data sources from the built environment to improve energy efficiency and comfort, and he's made it his mission to educate building industry professionals about the value of coding and data science. So over to you, Clayton. I'll just make you a presenter.
Awesome. Thanks, Daniel. Yeah, do I need, you're gonna make me presenter, or do I have to? Oh, perfect. Okay. Yeah, show my screen. All right, there we go. Should be able to see my screen, I guess. If not, just let me know. Okay, well, thank you so much, Daniel, for that introduction. Today, let's see here. Let me get, there we go. So today I'm going to talk about a topic that I'm super passionate about. It's all about learning to code and kind of the motivations and paths and different things that you as a industry professional and as an ASHRAE member, you're likely from mechanical system side or energy side or simulation side of things as well. So hopefully this is there's a lot of content here which is in that direction as well. So as Daniel mentioned, you can download the handout, I think, from the client here. You can also, if you have your phone, you want to scan this QR code and look at slides that way. There's also a link down at the bottom. I think it's great to have the slides while I'm giving the presentation, because there's a lot of links that you can click on and kind of explore and as I go through the content here. So first thing I will do is introduce my team. So the Building and Urban Data Science Lab here at NUS, we're a team of architects, engineers, computer science, data science professionals. We're very interdisciplinary. We look at all the different ways that you can leverage structured and unstructured data sets from the built environment mostly for energy and thermal comfort type research. So if you're interested, today I kind of scratched the surface of some of the research that we do, but if you'd like to check out more, you can check out our website. And if you're not familiar, I am at NUS, National University of Singapore. We're in the Department of the Built Environment, which is a name change. We used to be called the Department of Building, but we've rebranded to the Built Environment. And we are a department that's it's a more technical architecture department in a sense. We do have a Department of Architecture, which is like our sister department. We're something like a architectural engineering or sort of technical architecture faculty with lots of professors like me who do research in energy and things like that. So today, like I said, this is a topic that I'm really excited to talk about. The goal really is to convince you that learning to code, even basic coding, is useful. It's useful for whatever sort of job you have or workflow you have, and it's straightforward to get started with. And then I really want to show some of the tools and templates and different things that help people get started, and show you the paths that you can go down if you're interested, if you want to sort of explore and understand how to get started. We won't dive into any like actual code today. I think maybe that might be a relief to some of you. So I'll try to keep it light, keep it high level, and all about the motivation and the paths that someone could get going on if they're interested. So this is a few slides that I put at the beginning of a lot of the slide decks I give. What's wrong with the building and construction industry? What are some of the motivations, let's say, for learning new skills or incorporating new technologies? Of course, everyone's seen these advertisements. They've seen the hype of IoT and all these amazing technologies that we can incorporate into buildings to create data from a sensor perspective or IoT perspective. We're also probably quite familiar with all of the spatial data that's being created over the years. I was a mechanical designer long ago, and building information modeling was the cool new thing. That back then, that was 13 or 14 years ago. It still is the kind of cool new thing, and BIM is really slowly but surely taking its stage as the tool that people use to design buildings. So we have all these data. Where have these data gotten us? That's the question I like to ask. And this is an article that came out a few years back, 2017. So it's starting to get a little bit old, but it's focused on the US construction industry. And it's all about the lack of efficiency that we have at least in the construction side of the industry. In most industries, you have this economies of scale where building or whatever that industry is, as it gets bigger, efficiencies get built into that, and technology helps that. But in the building industry, at least the construction side of things, we are not doing super well. If you look at this graph on the left, you'll see construction is the red line that shows a value added per hour worked, which has actually gone down since the late 60s. Whereas you have agriculture, manufacturing, retail that have almost exponentially grew in productivity, mostly due to technology and innovation. And so there's a nice quote here: while we're all using iPhones, construction industry is in the Walkman phase. I love using this quote with my students because none of them have a clue what a Walkman is, but some of you probably do. It's old school cassette player. So there's various reasons for this. This is not a worldwide statistic, but I do see this in a lot of places like Singapore and Europe as well, where you have a lack of efficiency, sometimes even due to technology. You have building information models are great, but it also makes it very easy to change designs very rapidly, and sometimes that can even result in time efficiency being diminished. And by far the biggest issue from my perspective is that the built environment is we don't build phones, we don't build computers, we build buildings, and buildings are all unique, and they're all designed, constructed, and operated by different people. We don't get the same economies of scale as these other industries for various reasons. And so there's lots of reasons for this, and there's lots of potential solutions. However, one of those solutions, in my opinion, is to look at it from how do we learn new skills to be able to adapt the way that we leverage data from lots of buildings or from different sources in a faster way that allows us to be more time efficient. Here's a slide that's kind of just blasting you with a bunch of logos. These are just entities and companies and universities that I have personally sat down with over the last 15 years and talked to about IoT and data and how they use it and why and what are the bottlenecks and different things. So a lot of these experiences are through my research, through my PhD and my research here at NUS, as well as through being in the industry as well, like actually working for startup companies and design firms. And the feedback that I've always gotten in these discussions is that we have all these data, and this data come from the sources that I mentioned: spatial data, sensor data, and these data are just siloed. They're just sitting there. We build a BIM model in the design phase, and then we kind of just put it on a disk and throw it in the drawer. Of course, nobody uses disks anymore, so maybe a flash drive, right? We have BMS systems. We have all these sensors. Buildings are the original IoT system, and so we have all of these sensors, but we're not even sometimes storing those data. So we have tons of data, crap loads of data that we're not using, and there's not really a great understanding of how to use these data, how to build them into the business models of the companies that we work for or that we have, and a lot of that is due to a lack of understanding. Data literacy is what was one way I would put it. So because of that, how do we better leverage these data? How do we help the economy? Like, how do we help make our industry more scalable, more robust? How can we leverage these data to do that? And if you look at the options out there, I want to go through these very quickly. That you've got three kind of categories. The first one is just what we've always been doing, right? Spreadsheets, old school spreadsheets, good old trusty Microsoft Excel, let's say. Then you've got the new category of these newer tools that are coming out: Power BI, Tableau, there's Spotfire, there's all kinds of these, there's different companies out there that sell solutions or have solutions available. And then you have things like Python or high-level programming languages, which I'll talk about. So which of these should I focus on? Well, I'm here to give you maybe some guidance through an analogy, and I love analogies, so just bear with me. This is the second time I've showcased this analogy. The analogy really is like, how do I approach eating or feeding myself or my family? How do I nourish myself and my family with food and water and drinks and things like that? Well, essentially, there's a few different options. Well, the first thing you could do is the fastest, cheapest option. You could make a peanut butter and jelly sandwich. Since that is my suggestion, everyone now knows that I'm very much American, right? That's kind of the go-to PB&J, what Americans like to make, or fast food. Let's say you order McDonald's or some sort of fast food. Anyone can do this. Like, you don't have to have a lot of skill. It's very easy. You could even say that the food is tasty in a sense, but you're not going to do this every meal. And if you do this every meal, you're going to be unhealthy or just going to, it's not going to work out. So you're going to only do this occasionally, limited scope. Maybe your partner's the usual chef, they're out of town, and they're busy, and you have to cook that day. So maybe that's the option. So in this analogy, this is like using spreadsheets. So spreadsheets are simple to use. That is like the main reason everyone uses them. It's very easy to understand. I fill out these cells, and you can send them to your colleagues, and people really can kind of get a sense of what's going on. But spreadsheets are also unhealthy to use just exclusively if you're using bigger data sets, different types of data. You want to try to do more advanced techniques. You want to try to use time series data analysis or merge time series data sets. You're going to go nuts if you just use spreadsheets, if you start getting into these more advanced data sets. And so a lot of people don't. They don't even dive into these bigger data sets or more advanced techniques because they're really comfortable using spreadsheets. They like their PB&J, and they don't want to change. But let's say you do want to learn how to leverage these bigger things. Well, you could order from a restaurant, or you could go out to eat something a little nicer, more fancy. You can get a fast meal prepared by an expert, very nutritious, tasty if you want. But on the flip side, you also might have to pay. It may not be within your budget. You may not be able to eat at restaurants every single meal. And there's also limitations. So if you go to a restaurant, you can only order what's on the menu. You can't, most places, you can't just say, oh, I don't like anything on the menu, make me something different, right? So there's restrictions, especially if you have special diet or tastes, or you really crave some sort of food and so this is also some limitations. So Power BI, Tableau, these are all tools that I think kind of fit in this analogy in this sense, that they can be quite easy to use. You just, you order them, they can be quite effective, but you're sacrificing cost potentially, which may or may not be a problem, but you're also sacrificing the flexibility to kind of really get what you want, especially if you have some sort of weird problem or thing that you want to try to figure out. So what is the option with the most control, flexibility, etc.? You could just cook yourself, right? You figure out how to cook, you learn, you can create the meals exactly the way you want them. You can try to, if you have a special diet, you have special tastes, there's so much many more things and nuance that you can do when you learn to cook. But at the same time, learning to cook is also not easy, right? Everyone knows, we've all tried to cook something, right? Some of us are really good at it, some of us are not so good, some of us love doing it, love learning, and cooking is a lifelong skill if you try to go down that path. So that's where Python is, that's where coding is. You really have full control over what you can do, the budget, the scope, etc. But the flip side is, this is the downside, is that it takes a lot more effort, skill. The learning curve is different. I wouldn't say the learning curve is terrible or worse. It's just different. But it is something that really gives you the power to do what you want or need to do for yourself and your family. So I'm not here to tell you that you all need to learn how to cook every single meal. Of course not. There's going to be certain situations where you make a quick peanut butter and jelly sandwich. There's going to be situations where you go out to dinner to a restaurant, and there's going to be situations where you cook your own food. And in the same way, with data analytics, it's the same thing. You're going to have different options for different situations. Not every situation fits perfectly for every person. Everyone's a bit different in that way. And the path that you decide to take, or the balance of these different skills that you use or develop, is going to be more of a reflection on those around you. If you're around lots of people that love to cook or know how to cook, or you're from a family that loves to cook, you're probably going to cook, right? Same thing with coding. If you're surrounding yourself, or you're being exposed to people that code, you're probably also going to learn how to code. It also comes down to the intrinsic motivation of learning and wanting to learn to code, the passion that you might have behind it, or the hatred you might have for it once you get started. One or the other could happen. And so, thank you for bearing with my analogy. Hopefully it kind of got some message through. But I've been learning this over the last 4 years. I've been teaching Python to students in our programs here at NUS. And our students are in a program called Project and Facilities Management. So these are project managers. They're not even engineers. They're not computer science. They're not anything at the very technical side of things. But they're project managers. And so, and we've been successful. We've taught over 600 of these students over the last 4 years to learn the basics of coding. In addition, there's an open online course, an edX course that we deployed. My team deployed in 2020. So it's been out there for a little over, about a year and a few months. And we've had over 20,000 people participate from all over the world, mostly from English-speaking countries, majority, but lots of people from other parts of the world, Europe and all different corners of the world. And the feedback we've gotten is quite encouraging, because there's a lot of people that want to learn data analytics or coding, but also want it to be put in the context that they may care about, which is the construction and architecture context. So what I tell my students, what I'm telling you all, is that learning to code helps you with this. It teaches you to cook, in a sense. It helps you automate things. It helps you work with large data sets. It helps future-proof you, not only in the building industry, but in any industry. And you'll find that at least, places like Singapore, I don't know about Ireland or other places, but they're actually teaching grade school kids how to code these days, right? Using Python and using these basic, these high-level programming languages. So in 10, 20 years, you're going to find that this is going to be, the ability to be data literate is going to become a mainstream skill. So let's hope that you're kind of interested now. Let me give you some information on how to go in the direction of learning. So what are the key components and libraries and tools that if you undertake a Python course, so like the online course that I just showed, these are the things that you're going to be exposed to. First one is a library in the Python language called Pandas. So Python is very, very general purpose as a programming language. You can build websites, you can do data analysis, you can do anything basically technically with Python. But Pandas is the library that fits into Python, which is full of functions and data containers, as I like to call them, or data structures that allow Python to be used like Excel or like MATLAB or like these other analytics data analysis tools. So it's a really, really important library, and it's the foundation for the course that I teach and a lot of the other courses that you find that are practical courses on Python and data analysis. The next library, which is really important, is called the Seaborn library, and it is all about data visualization. So data viz is, it can be exploratory, it can be a way to showcase the results in a way that humans make decisions from it. So it's really, really important, and I found that this is really one of the first things that people get sort of like shocked by when they start programming, is that how many options they have for making really beautiful charts and graphics, far beyond what you could do usually in a spreadsheet software. Seaborn is not the only library. There's several others, which I won't go into now, but there's literally dozens of Python libraries that you can use. Seaborn I suggest because it's pretty straightforward to use. It's quite powerful, and the graphics look great. Scikit-learn. So this is where you're starting to get into the buzzwords, which we'll kind of talk a little bit about today, but not dive into detail, of classification, regression models, supervised learning, if you will, unsupervised learning in the form of clustering. Scikit-learn is your go-to like tool chest to go through and create these models, to train models, to pre-process data, to see outputs, visualize results, all kinds of things. So this is really like, if you want to dive into the world of AI or machine learning, Python is a great tool to learn. Beyond the three that I just showed you, there are literally thousands of other Python libraries. And so a lot of them are in the visualization field, data analytics, but you're also finding a lot of libraries specific to a very contextual application, such as energy simulation of buildings. For example, there are several packages, and I'll talk about some of the high-level efforts in that direction. I won't go through all the packages, but basically, if you have some sort of data problem, you can literally Google Python and your problem, and you'll usually pop up with some sort of library that's been tested and developed by a community and free to use. So there's lots of these libraries out there. I'll talk about libraries and examples here in a second to give a little more context to that. Another tool which has really helped people learn Python and get started with it is a platform called Jupyter. And Jupyter is really an interfacer. It's more like a development environment in a sense, where you have these what's called notebooks. And a Jupyter notebook is almost like a report, because you can kind of see a screenshot here. I'll show some examples in a few slides from now. You can see a screenshot here in the middle where it's basically a web page. You have text, which is explaining what you're doing. It has code cells, so you can actually see exactly what's happening. You can tell the story from beginning to end of this is the analysis story with the code built into it. And like I said, I'll show an example here in a second. The Kaggle platform. Kaggle is a platform that I use quite a bit. I'll talk about a Kaggle competition here in a second. There's a lot of machine learning competitions, data sets, code bases, discussion boards. It's really like the social media platform for data science in a sense. And my team plus other collaborators are using Kaggle as a way to crowdsource examples, machine learning and data science examples specific to the built environment, which I'll show here in a second. So those are kind of the generic tools. Now I want to dive into, more building industry specific things. And I'm going to focus on building performance analysis because that's probably one of the more mature parts of the Python for built environment communities. There are other communities beyond this which focus on digital construction or robotics and like BIM modeling, and there's all kinds of other tangents. But today I want to talk about building performance analysis because it is quite mature. There's quite a few examples to show. So Python for blank and building performance analysis. So Python for Energy Plus, for example. There is a brand new Python API for the Energy Plus engine that allows you to sort of run and manipulate the way that Energy Plus runs. You can pre and post process Energy Plus input and output data. And I put a photo here of Edwin Lee, the researcher at the National Renewable Energy Lab, who I just had a call with about a month ago, who showed me all kinds of really fun examples of using this Python API. You're basically using Python programming to interact with the way Energy Plus runs. So people have been trying for a long time to create interfaces and integrations of Energy Plus with other engines. With something like this Python API, that becomes more powerful. You can script those things up. It's more, there's lots of cool possibilities. I can't go into all of them. If you're interested, definitely reach out to Edwin. He is super keen to show people how cool that is. Open Studio, some of you might know of, is an open source platform developed by a lot of the labs in the US to use Energy Plus. You can now also interface with Open Studio. You can automate various things. You can, you can basically plug into the way Open Studio works using Python. You've got Modelica. So these are kind of the more complex open source communities. Modelica is really the library of simulation models that really gets you into the details. Like you can really model things in a very modular way using Modelica. And since day one, Modelica, the Modelica for Buildings team at LBNL has been developing a Python library alongside it called BuildingsPy, which allows you to do a lot of the processing. So let's take a step out into the more of the commercial tool environment. You have tools like Design Builder that have scripting engines built in. Python is one of those languages that you can use to script. You've got IESVE, which also they explicitly talk about Python scripting. They explicitly have sort of use cases and things like that. So of course these platforms have these user interfaces that a human gets in and creates the models and manipulates them, but you can also automate certain processes within these tools using scripting, and these platforms are building that in as a feature, as a touted feature that they want people to use, which is really exciting. You've got Rhino Grasshopper. That's a whole environment you see a lot of designers using, where they're sort of automating the way of creating the form of a building using Python. That's really common. And a lot of, if you go to any architecture graduate course, you'll see a lot of architects learning Python. In fact, I would say that a lot of architects have better Python skills than engineering students do sometimes coming out of university, because they've used Rhino Grasshopper and used Python to manipulate those models. You have kind of an ecosystem called Ladybug tools, which fits into the Rhino Grasshopper paradigm. Not only are these, Python's not only a catalyst for using these tools are built in Python. They're actually written in Python, and they're open source tools that if you're familiar with Python and how to code, you could actually even come in and help, create and improve the tools using your Python skills. The last one that I'll talk about is at the city level, city energy analysis, which is a pretty popular topic these days in the research and academic communities. It's starting to become, I think, a little more mainstream in practice, is creating district scale models to test the deployment of, let's say, district cooling, district heating, optimize systems like that, integrate with agent-based models that actually show how transport and energy can fit together. And so there's a platform called City Energy Analysis or Analyst that is also written in Python, and it's also a platform which is open source. And if you're able to, if you understand a bit of Python, you can also dig into the guts of this software or use it in a better way, I would say. So there's dozens of other examples. I don't want to run out of time tonight going through all the different paths, you know, that you can go down. But this is just one subset of the built environments industry, which is building simulation or building energy analysis. Like I said before, you also have you know, construction management, you have the design process, you've got digital fabrication, robotics, things like that. These are all innovating, you know, new directions that learning Python will also have an impact because of these type of tools. So let's say that you're, okay, maybe I've convinced you that this is a good path to go down. Maybe you're the type of person that likes to learn really bit by bit, you know, like I want to take tutorial A, B, C, D, whatever. Some people learn really well that way. I'm the type of person that learns really well by seeing other people do something that I think is interesting, and I take my situation and try to learn from what they've done. So basically, almost like a recipe, I call it recipes or examples or whatever. These are, you know, somebody doing an energy analysis on a building in, you know, in Tokyo, and I've got a building in Singapore, and I want to do a similar type of analysis. I can basically take their analysis and I can adapt it to my needs. I can change, obviously, the data source. I can add my boundary conditions. I can add my weather file. I can do all these different things. So I call these recipes, and this is really the foundation for learning how to code for many people, including myself. And there are different platforms which host these examples, and they're becoming more and more common. GitHub is one of them. Kaggle, well, let me talk about GitHub. GitHub is a software repository platform, if you're not familiar, where you can find like a lot of open source projects, a lot of data sets, a lot of example code for tons of applications. Kaggle, I talked about earlier, Kaggle Notebooks and Kaggle are another place. And to show you an example of something on Kaggle related to our industry and related to ASHRAE, of course, which you all are familiar with, let's talk a little bit about a competition on the Kaggle platform called the Great Energy Predictor 3 competition. And this is something that I've worked on with a larger team of people. The acknowledgements will be at the end. I'll definitely highlight the people that helped with this. But ASHRAE was the main sponsor. This is a machine learning competition where contestants were taking training data from energy meters, whole building energy meters, from quite a few meters, over 2,300 meters from across North America and Europe, and building machine learning models to predict sort of the second half of the data set called the test data set. And this is some of you might think, you know, why would you call a competition the Great Energy Predictor 3 competition? Well, it's actually a resurrection of competitions that happened in the mid to late 1990s that ASHRAE sponsored. These were led by ASHRAE's TC 4.7, by Jeff Haberl and some of his colleagues at the time, where they actually had machine learning competitions in the mid 90s where they would actually mail floppy disks to people that have data on it. People would run models and do analysis and make predictions, and they would mail their submissions back on a floppy disk as well. So we brought out the spirit of those old competitions. We modernized it by putting it on the Kaggle platform, and there's lots of really cool things that came out of it, which I'll talk about now. And the goal of this, from a research perspective, is benchmarking. So we wanted a large data set. We wanted a lot of people looking at that data set with a common objective. And then what you get out of that is the ability to compare the different methods coming out of that process. So you can say, I've got algorithm A, B, and C. I can really compare those against each other because we're using the same data set and the same time frame, basically. So the way the competition worked was people could download the data, they could run all these models, do analysis, visualize the data, create all kinds of examples. When they created a machine learning model, they could then upload a prediction and submit it to the platform. And then immediately they would see on what's called the public leaderboard where their submission performed. So behind the scenes, there was the test holdout data set is comparing the submission prediction to the test data set. and giving you an instantaneous score. During the competition, which was about 90 days, you could give up to 2 submissions per day. You could create teams of up to 5 people. And so you had lots of people kind of jostling around on the leaderboard, going up and down, learning new things, processing the data in different cool ways, all with the intent of getting the best performing model to compete for prize money that ASHRAE actually sponsored, $25,000 US prize money, as well as various other goodies that you get on the platform when you win. It was really a great success in a sense that we got lots of people to look at the context, to give submissions, to create content, and to really create I think, a really exciting competition. We had over 4,000 participants across 3,600 teams from all over the world. And amongst those teams, there was almost 40,000 total predictions or submissions. The top teams you can see here, mostly people from the data science communities, mostly from all across the world. A lot of them having a little bit of building industry experience. Few of them having experience in metering data and the processing of metering data, which we'll talk about here in a second. So really, and the top 5 winners were opening their solutions, giving their entire code base for us to give to the community, to put as an open source license, to put on GitHub. There's a bunch of videos, so you can actually follow this link if you're interested. You can see all the solutions, but also videos explaining how the solutions were created, what were the process, the steps in the process that the people took, and things like that. The winning solutions themselves, there are 4 kind of key takeaways. The winning solutions were large ensembles. They were relatively complex models. However, we asked the winners to create suggested simplified models or simplified techniques where you could get almost the same level of accuracy, but without all of the complexity and all the code and things like that. Point 2, the gradient boosting tree models, that was really came out as the best type of modeling, at least for this type of data in this context. So we know, so people don't have to try 20 different model types. Point number 3 and 4, I think, are really key. It's really worth emphasizing that some of the winners had engineering backgrounds. Some of them, in fact, the #1 team states that they're probably won because they were able to pre-process the data better than anyone else, meaning they removed areas of data that were noisy, that had signals that would throw the model off. They basically were the smartest ones to remove certain parts of the training data set. So it was great. We showed that engineering is, contextual understanding of the application is important. You can't just toss data science at something and expect you to get the best results, which was really interesting. So the thing that I think, a lot of you might be just getting started with programming. So a lot of that stuff didn't maybe make as much sense, but I want you to pay attention to this slide. This slide is the cool part. There was 450 workflows, machine learning workflows, data science workflows that were shared in an open source way. Most of these in Python, and a significant number of these which are considered starter code, beginner code, kind of exploratory data analysis, etc. So these are notebooks, Kaggle notebooks, which if you're just getting started learning how to code, these will be the notebooks that will do you the most good and provide the most benefit. So we had tons of these notebooks, these recipes, if you will. This is my favorite part of the outputs of the competition. Yeah, we have all these fancy models, we have all this, really complex stuff, but we also have stuff that helps people get started to learn to code, which is really exciting. Here's an example of one of those energy analysis workflows. This is a notebook format. You can kind of see the person who created this notebook gives a little explanation. First we look at the data files. There are a total of 6 of them, blah, 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 blah. Let's take a look at the data. Let's visualize it in certain ways. So you can see this is something that if you're just getting started coding, maybe, you've never written a line of code in your life, but you can still follow these analyses flows and you can still get a sense of what's happening. You can see the code that it actually takes, and you can actually even copy and paste that code or learn from that code, or even in Kaggle, you can actually make a clone or a copy of this notebook and play around with it yourself and change various things and sort of learn from it. You can vote on the notebook. So if this notebook had over 850 upvotes, if you can see in the sort of upper right-hand corner, which means that a lot of people really found this notebook super valuable and useful. So this platform is, like I said, Kaggle is like it's like a social media, let's say, for people that are wanting to learn machine learning and how to code and things like that. So beyond Kaggle, what we did is we opened the data set from the competition, as much of the data as we possibly could. We even added quite a few more meters that we didn't have in the competition. This is in a data set called the Building Data Genome 2 project. This is the second iteration of a large sort of open data set that we're sharing with the community, which is devoted for, of course, researchers, but also for people who want to learn to code and have an example data set to play around with. On Kaggle, we now, my team in the last about 6 months, we've started collecting data sets from other parts of the building industry. So here you can see 9 of those data sets. A few of them are mine, but most of these are not it's not my data sets. These are open data sets that I found on the internet. Most of them from a research publication called Scientific Data. So not only do you get a data set, you also get a really well-written paper, which kind of tells you where the data came from, who created it, what it means, all these different things. And you can see here that there's fault detection data set from LVNL. There's the ASHRAE Global Thermal Comfort Database too, if you've probably heard of that, if you're from that community. You've got BMS data sets, you've got occupant presence data sets. And so when we have these on Kaggle now, we're trying to make it into what I call a sandbox. We're requesting anybody who has data sets that they want to share to reach out to me or to just put them on Kaggle themselves. And we want to create over the next couple of years like a larger and larger data set, library of data sets. And this is part of the effort from the IEA Annex 81 community, which is focused on data-driven. In the future, we'd like to, like I said, create this library of data sets. On Kaggle, we also have what's called tasks and task submissions. So if you have a data set and you have some question you want to ask from that data set, this is something that's more qualitative. You want to say, using human building interaction data, I want to know how, what is the time range that people usually use buildings or something like that. You could ask those as questions and create tasks, and then people in the community could try to answer those questions using notebooks. So it's kind of like this, like I said, this crowdsourcing environment where you can learn and give back and really learn as a community. We're thinking about great energy predictor for competition. We're thinking about something related to more on the BMS data side, automatic tagging of data points, which we think would be super useful. That's something that's underway as well. So this is kind of a little tangent here. If you have a data set that you'd like to share, we'd love to, let me know. There's a link here where you can donate building data if you'd like, or you can send me an email. There'll be an email address at the end of the talk, which you can also send to me. Last but not least, this is the last section, a few more slides left. This is the most important point of the talk from my perspective, how to get and maintain motivation to learn this stuff. So I want to tell a little story about when I first learned to code. So why am I here, on my soapbox, yelling at my computer at 9 p.m. about Python? Well, it's because I got started in the early 2010s, about 2010. I was working on a model calibration project. The vendor who's supplying the meter data sort of swore that they could only give me time series meter data in PDF version, PDF files. Secretly, I suspect that they just didn't want to share the data with me, so they gave it to me in some format that they didn't think I would be able to, to crack into. So that was the first time I ever learned Python. I literally just how to crack into PDFs, how to get data out of PDFs. And I found a Python library which allowed me to do it relatively easily, even though it was my first programming experience. There was a specific PDF cracking library that allowed me to get in there, grab that data, put that data into a spreadsheet, and actually visualize it and actually do that analysis. A few, I think, months later, I was working on another project where a building owner said, we want you to do an analysis. Here's a file. Here's a flash drive that's got 20 gigabyte, database backup or whatever on it. Can you do an analysis? Of course, Excel can't open that file. So this is when I discovered the Pandas library. Pandas has different mechanisms for easily taking like a big flat file like this and sort of chunking it out into these and loading it a part at a time, which allowed me to analyze the data, visualize the data, and get it in a format that I could use in a better way. A few months later, I wanted to model VRV systems in Energy Plus. I had these special VRV units that nobody had ever done in the model, and I needed to create my own performance curves for that model. And I just couldn't figure out how to do like relatively simple regression. I probably could have succeeded if I would have persevered, but I just didn't figure out how to do it in Excel. And I found that in Python, it was like a piece of cake. It was literally a few lines of code to do this regression, to create the performance curve and the coefficients that go into the Energy Plus model. So my point is that when you learn to code, in my opinion, by far the best way to learn is take a chunk of your existing job and find data that relates to that and figure out a way that you can use programming or Python to transform that data into something you care about. It's good to pick big, crazy data sets that nobody else wants to touch because Excel won't open those files. You can use online tutorials like my course if you want to get started and you want to get that context, you want to get some momentum. But I feel like the best way to learn is to actually just do data science on things that you really care about. Because once you solve those problems, you just feel like a hero, superhero. I say freaking superhero. So that's really the motivation that I think drives people, is that you see the things that you can do using a new skill set, which gets you through that learning curve that's so much different than using tools that are more easy to use. It's similar back, to the cooking analogy. When you make a beautiful dish that everyone enjoys, that feedback is what keeps you going, keeps you motivated. So thank you so much. There's tons of people that contributed to a lot of the content that I've done here. I just wanted to give a shout out to them. I'm not going to list them off, but also the National Research Foundation of Singapore supported a lot of this, as well as NUS. So with that, I will take any questions. I think we've got, about 13 minutes for Q&A. I'd love to hear if anyone has questions.
Perfect. Thanks very much, Clayton. Thanks very much for a really interesting talk. I covered a lot of different aspects of data science. So thanks very much for that. While we're waiting for questions to come in, because I think so. If anyone does have questions for Clayton, just submit them through the questions tab. But while we're waiting, I just had a couple myself actually.
Sure. Yeah.
One was, I suppose you talked a bit about the use of data science techniques for analysis of building performance simulation data, which is generally quite well structured in that you run an IES model or an Energy Plus model and it comes out in the same way. Whereas with buildings, one of the issues that people typically face is that the data structure is always different. And I know you kind of touched on this with the next iteration of the Great Energy Predictor. But I was wondering if you had any thoughts or comments about reusability of code if you're developing Python code. Obviously, if you're doing it for one building, there's a big learning curve to do this, and I wonder if that's a deterrent for people to get stuck in because they feel like they have to reinvent it every time they go to a new building.
That's a great question, and that really drives at the point I tried to make earlier, that one of our biggest issues in the built environment is that every building is different. The points are different, the way the building's designed, the way the points are labeled, So let me answer the question first from the perspective of a very practical base level. So Python is used by people from all kinds of industries to load, process, clean, sort of, there's basically a lot of these libraries are devoted to sort of fuzzy logic when it comes to, for example, let's say you've got a point list of BMS points, right? So there's a ton of text mining and text analysis libraries in Python that could allow you to try to figure out, okay, is TEMP temperature of air, or is it water, or whatever? So there are ways that you could sort of process that data to be able to figure out what's going on in a data set which is very messy, that has a lot of heterogeneity and all these different things. And that code can often be repurposed for different buildings, because every time you bring in a new data set, you can probably reuse the code to a certain extent. So that's really like the practical thing that people would run into if they start using Python today. The competition that we're thinking about doing in the future is to have machine learning help with that a little bit. So if you've got, let's say, data from 50 buildings, and let's go back to the point labeling situation. You could start to train models to recognize different patterns in the way points are labeled, so that when you come into a brand new building that you have no idea what the points labels mean, possibly that model could help assist you in that mapping of those points to whatever you recognize or whatever system you use. And this is similar to like Google Translate, right? We use Google Translate. If I don't speak Italian, I'll try to put my, I'll put a text in Italian into Google Translate, and then it'll do an okay job. The AI will bring that text to a point where I can probably understand it, but it won't be perfect. What we're kind of thinking is something like Google Translate for buildings, where if you have a new building that comes in, you can apply this engine to it. It tries to translate it, whatever metadata you're trying to extract, let's say point labels, into something that is, aligns with what you expect or what your company expects in a sense. So that's a lot more advanced, and that's very exploratory, but that's kind of the direction that we think would be really cool. It would be very interesting to do. If that makes sense.
Yeah, thanks very much, Clayton. I've got no other audience questions at the moment, so I'll ask you another one. Just about operational data for, I suppose, for BMS vendors. Do you see, because you mentioned a lot of the building simulation software vendors that are offering script interfaces to their software now. Do you see the same happening at all in, you mentioned a couple of conversations you've had at the beginning with different industry stakeholders, including some controls companies. So I'm just wondering, do you see any of that happening in the control space as well?
Absolutely, absolutely. So if you look at, for example, I won't name names of vendors, but if you look at the major vendors of building management systems, a lot of them are including a feature called a REST API. And a REST API is it's like a socket that you can pull and push information from. And REST APIs are common across the internet. Like every major platform has a way you can either call data or send data in using code. And a lot of times people use Python for that. So Python has tons of libraries that interact with REST APIs. So for example, I was a part of a project here in Singapore. This was even this project kicked off in even like 2012, 2013. And we were able to connect into the BMS system through a REST API, query the sort of data model and database using Python in a very automated way. We were able to get point lists. We were able to do all these things. Of course, you could do some of these things through the interface of the building management system, but I could do it programmatically. So I could automate that, or I could create a script which every hour calls the database, grabs data, and pushes it into another database. And this was back in 2012. This is right towards the beginning of when I was really developing my coding skills. So even somebody with that level of coding skills, I was able to interact with these APIs, pull data, do some processing, push to my own database without learning really sophisticated things, basically. So you're starting to see more of these type of features like REST APIs in BMS systems. If you look at like Revit and Autodesk, like it's called like a Revit Python shell, which means you can manipulate the guts of Revit using Python, which is kind of like an API. It's not a REST API, but in a sense, it's an API. So these API connections and using programming to interact with those connections is in pretty much every major software in the building industry. It's just that not a lot of people know about it. Not a lot of people use it. People don't have the skills very often to use that unless they have gone down this path of learning to code. Yeah.
Thanks very much, Clayton. So I'm just getting comments in just to say thanks for a great presentation, but I haven't got any additional questions from the audience. So
okay.
Oh, actually, sorry, there's two have just popped in at once here, so just check.
My talk is
okay. Maybe I'll get one of these.
So informative. Nobody has questions.
So there was one question regarding advice regarding handling metadata.
Like metadata of BMS systems, or
I presume
like
so. I haven't got any additional questions.
Yeah. So metadata related to well, okay. So if I go back to the point labeling problem I brought up, so that a label of a BMS data point is part of its metadata. There are these new standards that are coming out, or frameworks for metadata standardization, such as Haystack, Brick. If you're familiar with the BMS community, you're probably familiar with at least those two. Brick, I'm very familiar with. I'm pretty familiar with the guys that are like working on the open source project behind the scenes, and they're building Python tools basically for everything within Brick. I think Haystack as well. If you Google around, you'll find some Python-ish stuff out there that's related to Haystack as well. So metadata standardization is, at least for Brick, I can say that if you know how to use Python, you can use the tools that they've developed, open source tools that they've developed right out of the box quite easily. So if you talk about metadata related to building information models, like I said, and we're going to start, my team is going to start working on more examples related to BIM and energy simulation on Kaggle, so that people can see, okay, I've got this, maybe GBA XML file that came out of Revit. How can I actually use that, or how can I crack into that XML file? Python has a lot of libraries related to XML, so you could parse that XML file. You could make it into a table. You can do all kinds of interesting things depending on what your goal is, or what your application is. So there's lots of metadata in the building industry. So long story short, yeah, I think Python is a good tool to play around with that.
Okay. Thanks very much, Clayton. I think we'll close the questions there. And just before I go to the closing announcements, I don't know if you wanted to give I saw your next iteration of the course. Is it starting next week? Is it 17th?
Yes. Oh, thanks, Daniel. Yeah. So the course is relaunching next week. It will go for about 9 months. You can sign up anytime during that 9-month period. It's completely free to see all of the video content related to the course. You can sign up for a verified certificate, which essentially just gives you the opportunity to get if you do finish all the quizzes and things, you get like a certificate that says that you finished them. So that's completely optional. I'm happy whatever you end up doing. But yeah, thank you. Thanks, Daniel, for helping me plug that. I think it's, the more people that learn this, the more the community grows. We reach a critical mass, and I think it'll become something that becomes more mainstream, hopefully. So yeah, awesome.
That's perfect. There was a question just to ask for the link for the course. I don't know if you can share it in the, it's on one of your slides, right?
Yes, but I can also share the link. Yes, absolutely. Let me get that pulled up here.
If you can share it in the chat,
yes.
You can send it to everyone. Just in the meantime, while you're getting that, I'll just go through a couple of closing announcements. So just very briefly, this is just to show our new ASHRAE Ireland board for the 2021-22 term. If you do have any questions about or ongoing activities in the Ireland chapter, feel free to reach out to any of us, or if you want to volunteer to help out, please don't hesitate to contact us directly. Also, just if you want to stay in touch with our upcoming activities and events, there's links here to our various social media channels and our mailing list as well. So if you go to our website, ashraeireland.org, and under the About section, there's a link to subscribe to our mailing list if you haven't already done so. And lastly, just a word of thanks to all of our sponsors whose support really make our ongoing activities possible. So thank you very much. And thanks everyone for attending today. Clayton, have you been able to share the link to the course? Yeah,
I did, but I'm not sure if it got to everybody. So I would just suggest you can just Google edX, EDX, and then architecture construction, and it'll be the first thing that comes up on the search engine.
Okay, I think I've shared to everyone, so it should have gone to everyone in the chat.
Perfect.
Perfect. Yeah. If not, I'll make sure it goes around to everyone on the website afterwards when we upload the presentation. So thanks again, Clayton, for your time today. I know it's late in the evening in Singapore, so thanks so much for joining us, and hopefully we'll see you in person in Ireland sometime soon.
I hope so. I'll let you guys know. Absolutely.
Okay. Thanks very much. Thanks, everybody. Have a good day.
Thanks, everyone. Thanks, Daniel.